6.2. The inverse of a function is found by swapping x and y values. Okay. So exchanging x, that should just be programmed in your head. Inverse means exchanging x and y values. That means, right? What is domain? Domain is all of the x values that exist for a specific function. Range is all of the y values that exist for a specific function. Now, if we look for the inverse and if we swap x and y, then everything related to x and y will also swap. So the domain of a relation becomes the range, and the range becomes the domain, right? So domain and range also switch. Now, take a look at this. I know there are brackets here. So take a look at this one. If we want to find the inverse of this relation, okay, all I need to do, again, put it in the brackets, in the curly brackets. All you do is take each of these coordinates and just swap the x and the y. So 1, 3 becomes 3, 1, 3, 6, 6, 0, 0, 1. Okay, that's it. So do you see, for the first one, the domain would have been 1, 6, and 0, right? Now, that is the range. Do you see that? Like the domain and range just switched, okay? All right, next up, why don't we graph these? Okay, let's graph the original. So I'm going to graph the original using purple. X equals 1, y equals 3. X equals, oh, sorry. X equals 6, y equals 3. Right? X equals 0, y equals 6. X equals 1, y equals 0. Is this a function? No, which is fine because we've been talking about a relation. Okay, now, so for the first one, 1, 3, right? What is the corresponding one now? 3, 1. 1, 2, 3, 1. Okay? Look at this. Do you see how it's the mirror image of its corresponding point? Right? And what's the next one? 3, 6, right? Where is 3, 6? 1, 2, 3, 6. It's the mirror image of its corresponding point here. Look. Oh, why can't I do that? Do you see that? The mirror image around that line, y equals x. The next one is 6, 0. 6, 0. Look at that one. Its corresponding one was 0, 6. And look, that's the mirror image around that red line. And finally, 1, 0 becomes 0, 1. And that's also the mirror image around the line that's drawn in red. What is that line in red? What's the equation for it? Y equals what? Y equals x. Okay, so what happens? We just graphed a relation in purple. Then we graphed the inverse of that relation. And we saw that every single point is the reflection of its corresponding point over the line y equals x. It's the mirror image around the line y equals x. So that's a very, very special deal about inverses. Okay? So the line f of x equals x is the reflection of the function and its inverse. Okay? So going back, what is the domain and the range of the original relation? We already touched on this. The domain is 0, 1, 6, right? And what is the range? 0, 3, and 6, right? From the original relation. So now, what happens to the domain? What is the domain and the range of the inverse? What is the domain? So the domain of the inverse here is 3, 6, and 0. So 0, 3, 6. And the range is 1, 6, and 0, like we said before. So 0, 1, and 6, right? So do you see how the domain of the original became the range of the inverse and vice versa? Okay? All right. So how to find an inverse if you have a function? To find an inverse, so first of all, if you have a function f of x, the inverse is written as f to the minus 1 of x. But we never read it as f to the minus 1 of x. We say f inverse of x, or the inverse of f of x. Okay? Now, step 1, you rewrite f of x as y. Just relabel it. No math there. Next, exchange x and y in the equation. Solve for y and then replace y with f inverse. So let's go ahead and do that. Here I have f of x is equal to half x plus 3. I'm just going to rewrite it as y equals half x plus 3, right? Now, interchange x and y. So x equals half y plus 3. Now I need to solve for y. Subtract 3 from both sides. X minus 3 is half y. Multiply everything by 2. So I get 2x minus 6 is equal to y. I'm sorry. Okay, so now we found y is equal to 2x minus 6, but we can't leave it like that. In fact, if you leave it like that, it'll be minus 1. You have to rewrite it as f inverse of x is 2x minus 6. Okay? All right. So now we're going to graph the function and its inverse. The original function, f of x, is half x plus 3. So let's go ahead and graph that. I go up to 3, up 1, over 2, right? And graph this. Okay, so I'm going to label that f of x because I don't want my graphs to get confused with each other. Next up, negative 6, up 2, over 1. Okay, do you see how, again, so we're going to label this f inverse of x. Do you see how the two are reflections of each other around the line y equals x, right? And that's got to happen every single time. All right, quickly, let's do the other one. So y equals x squared plus 3. Y, okay, now let's solve for, let's exchange x and y. So x equals y squared plus 3. I'm going to solve for y, so I have to subtract 3 from both sides. Now what am I going to do? Take a square root. So y is equal to how much? Just that? Plus or minus square root of x minus 3. So now f inverse of x is plus or minus the square root of x minus 3. Okay, hang on. So now let's graph this one. Okay, x squared plus 3. Oh my gosh, we are experts at this now. Yeah, easy. Remember you guys used to think that was challenging? Whew. Okay, so here we go. All right, now when I have anything equal to its plus or minus, remember that's a shorthand way. It's a condensed way of writing everything. So really, I have two functions here. I have f inverse of x is equal to root x minus 3. Why don't we graph that? That's the square root. And now you can kind of see why I taught this after the other one. So I could use these examples too, and not just linear functions. So we go to 3, up 1, over 1, up 4, over 4, 1, 2, 3, 4, up 2. That's how that looks. And now I want to graph f inverse of x is equal to negative x minus 3. Whoa. Whoa. And there you go. And you see how the two are symmetric around the line. Y equals x. That is so cool. What's more, this is important. If I just take this part of it, that corresponds to this part. Okay? And if I just take this part, that corresponds to this part. Wowie, wow, wow, wow.
My jaw just dropped.
It's impressive. Because that's going to be important in a little bit. Because is the original f of x a function?
Yes.
Is f inverse a function? No. So that, but if I only take one arm, is it a function? Yes. So that's going to be important later. Okay. So, in fact, it's going to be important right now.
Wait, can I ask you?
Wait. Okay. So, you see how, okay, look at this one. Original is a function. Inverse, also a function. Okay? We say, for the first one, f of x has an inverse function. In the second example that we did, the parabola, the original is a function, the inverse is not a function. So the wording is f of x does not have an inverse function. It's got an inverse, but it doesn't have an inverse function because that inverse isn't a function. That's the code word, right? It's like math slang, right? It's like saying, right? Okay. So a function has an inverse function if the original function's graph passes the horizontal line test. So now, that means, did we really have to, once we saw this original parabola, f of x, did we really have to wait for us to graph the inverse to see if it's a function? No. Okay, how can you tell if something is a function? It passes the vertical line test. Now, if a function passes the horizontal line test, then its inverse will be a function, right? Because look, I have function, inverse, it's just lying on its side. So since this does not pass the horizontal line test, its inverse will not pass the vertical line test, okay? All right. So if it passes the horizontal line test, it's called a one-to-one function, okay? Okay, so verifying inverses. Now, you're given two functions, right? And somebody says these two are inverses, and you're like, no, it's not. And so rather than, battling it out, you're like, let's test it. Let's verify that they're inverses. There is a theorem, believe it or not. So the theorem says this: f of x and g of x are inverses if and only if f of g of x equals x and g of f of x equals x. Okay, so okay, so let's take a look at this. Determine whether each pair of functions are inverse functions. I'm going to talk about wording in a little bit, but first let's do this. What you are going to do is you're going to split your work area into two. In the first area, you're going to find f of g of x. Okay? So that means I'm going to take g of x and insert it into f of x, right? In here. So this is going to be 3 times g of x plus 9. Let's simplify. Distribute x minus 9 plus 9. So f of g of x is equal to x. Now, in here, let's do g of f of x. So now I'm going to put I'm going to put f into g. So this is 1/3 3x plus 9 minus 3. Okay, distribute. So x plus 3 minus 3, what's g of f of x? X. Oh my gosh, because I got x for both of them, yes, they are inverses. So now, two things. First one, it has to be x and x. You can't get like, just because, you can't get like 0 and 0 and say, oh, they're the same. No. It has to be x and x. It's an all or nothing deal. This is math. We don't do exceptions, okay? Now, plain x. That's number one. Number two, a little bit about notation. Okay, somebody is definitely going to ask me, well, can't I just take f of x, find the inverse, and see that it's the same as this? Okay, no. There is a little bit of notation difference here. This word here, determine, most of the time it says verify. And when it says verify, you have to use the theorem to verify. You cannot just take the shortcut, find the inverse of this, and say, look, it's the same as g of x. Okay, again, this is a math thing. We're very formal when it comes to these theorems. Okay, all right. So let's go ahead and do another one. F of g of x. And you know what? Just for fun, I'm going to use the other notation this time. Oops. So I'm going to put g into here. So let's do that. That's going to be, huh? It looks bad, but it's not bad. So don't judge a book by its cover, guys. Come on, this is math. We got to have faith in the math. If the math tells you something, who are we to question it? So 2 times g of x squared minus 1. Now, what's the square of a square root? Nothing. It goes away. So 2 times x plus 1 over 2 minus 1. The 2's go away. X plus 1 minus 1. F of g of x is equal to x, halfway there. Now, this is an all or nothing deal. So if it fails on the first one, you can stop. However, getting an x here doesn't allow you to stop because it's an all or nothing deal. You got to go all the way. Okay, so next, g of f of x. So now, the square root of, we're going to put f of x into x here. 2x squared minus 1 plus 1 over 2. These go away. 2x squared over 2. Oh my gosh. This is the square root of x squared. So what's g of f of x? X, yes. So they are inverses, right? So don't let the, don't let the complicatedness, lead you astray. Okay, so let's do this one. F of g of x. We're going to put g of x into this x here. So 2 times half x plus 1 plus 5, distribute, x plus 2 plus 5. Oh, that's an x plus 7. No. Okay, so this is actually, Stop there. It's all or nothing. This is actually the reason why I had put determined before, because I had an example, that was not going to work out. When it says verify, they are inverses, and you are asked to use the theorem to prove that they are. Okay, just like in geometry when you had proofs, there was never a case where like it didn't work, right? Like they all worked. You just had to prove that they worked, right? It's the same here. Okay, so use the horizontal line test to determine whether the inverse of each function is also a function. Okay, x cubed. What do cubic functions look like? Right. So x cubed minus 4 will look like that. Will that pass the horizontal line test?
Yeah.
Yes, right? Because if you draw a series of horizontal lines, imaginary lines, each horizontal line will only pass the graph one time. Now, what about the next one? The next one, okay, now look. When it comes to cubic functions, don't just take it at face value, because it is possible for a cubic function, let's say, to look like this, where it doesn't necessarily pass the horizontal line test. So when it's complicated, when it's more complex of a function and you're not absolutely 100% sure on the homework, go ahead and plug it into your calculator and graph it. In this case, this also is going to pass the horizontal line test, okay? But just be aware of that pitfall. Okay, and with that, you are ready to start on your homework.